Hello again. Let's continue talking about lines. So this is a lines video part 2, where we're going to get into skew and intersecting lines. And the other one got long, so we're just making this a separate part. Now, if you have your notes out, you should have this set up right here where you have lines that can either be intersecting, that look like that, or skew, that look like that. Skew lines are lines that don't go in the same direction, but also don't touch. So they're really like intersecting lines where one is lifted off of the other. And to figure out whether lines are intersecting or skew, there are a bunch of different ways to do it. But the way I do it is I basically assume they're intersecting, try to find the point of intersection, and then if I can't, realize that they're skew. So that's what we're about to do. There are a set of steps here. I'm not going to read through all of them. I'm just going to do them as I work. But we do have steps for deciding if they are intersecting or skew. You can read them later if you feel that you need to. Let's try it. Determine whether the lines x equals 2t minus 2, y equals 9 minus t, z equals 7t plus 1, and 2 minus x over 2, y minus 1 over 3z plus 9 are skew or intersecting. Like I said before, I don't really like the symmetric equation of a line very much, so I'm going to change it into parametric form because guess what? We kind of need it in parametric form for this. So if I'm going to put this in parametric form, this is really going to be, let's see, this is x minus 2 over negative 2. So in parametric form, this is x equals negative 2t plus 2, y equals 3t plus 1, z equals 1t minus 9. And if I want to know if these intersect, I have to say, well, if lines intersect, then there's a point where the x and the x, the y and the y, and the z line up. Fine. That means this and this have to line up at some point. So 2t minus 2 equals negative 2t plus 2. Except here's the thing. The t for one line and the t for another line aren't the same t. When we did parametric equations, or when maybe you've done parametric equations in the past, it's the idea that imagine that these are planes. When planes' paths cross, either A, at some point they were in the same location in the sky, or B, at some point they collided. B would be very bad. A would be quite all right. But the point is, each plane has its own time, all right? And we're just interested in whether these lines cross, not whether they collide as they are growing in time. Long story short, what that means is I have to redesignate these as T1s and these as T2s in order to solve this equation. If you look in your book, they make one T's and the other one S's. But what kind of moron uses S as a variable? It looks like a 5. So I don't do that. I just call them T1 and T2. You're not a moron if you use S. I'm just trying to make this video somewhat interesting while I talk about intersecting lines. Okay? Okay. X equals X. Well, I have two variables. If I have two variables, I need two equations. So now I'm going to set Y equal to Y. 9 minus T1 equals 3T2 plus 1. I could also set Z equal to Z, but since I have two unknowns, I only need two equations, and I almost always pick X and Y, unless there's a compelling reason to pick X and Z or Y and Z. Okay? Okay. I need to solve this equation. I have two unknowns. They're stacked pretty neatly. I think I'm going to do elimination. I'm going to take this second equation. I am going to distribute a 2, which makes my second equation 18 minus 2t1 equals 6t2 plus 2. And then if I add this one to that one, my t1s are going to eliminate themselves. So these add to 0. Negative 2 plus 18 is 16. 6t2 minus 2t2 is 4t2. 2 plus 2 is 4. That means 12 equals 4t2, and t2 is 3. Now I need to go back and find T1. So 9 minus T1 equals 3T2 plus 1. So negative T1 equals, well, this is a 9 and that's a 9, 1. So T1 equals negative 1. So that tells me the paths of these two airplanes have the potential to cross at one of them T equals negative 1 and the other one T equals 3. Now let's see if those paths cross one plane path going above the other plane path or the plane paths exactly intersecting. We do that by plugging in T1 and T2. So I am going to plug T1 back into this first line, and I'm going to get x equals negative 2 minus 2 is negative 4. Y equals, hold on, change my status here to 2 not disturb. Thank you. Y equals 9 minus T1, so that's going to be 10. And z equals negative 7 plus 1 is negative 6. And then in L2, when T2 equals 3, x is going to equal negative 6 plus 2, which is negative 4. Y equals 9 plus 1, which is 10. Z equals 3 minus 9, which is negative 6. I got the exact same point, which means that these lines will intersect. What would it look like if they were skew? The z's wouldn't match, but they do, so these intersect. So therefore, L1 and L2 intersect at negative 4, 10, negative 6. Let's do another one. So, determine whether these lines are skew or intersecting. Fine, I'll do it, but only because they told me to. Well, 3, 2, 1, 3, 2, 3, so I know they're not parallel or coinciding. That's why I didn't even offer that up. If they're skew intersecting, so this I'm going to set equal to that. 3t1 minus 5 equals 3t2. Y set equal to y, 2t, 2t. So I'm going to have 2t1 equals 2t2 minus 5. And I don't need to set the z's equal. I could. I just don't want to. All right. I'm going to go for elimination again, except this time I'm going to need to multiply. So I'm going to multiply this thing by 2 and this thing by negative 3, which is going to give me 6t1 minus 10 equals 6t2. And then I'm going to multiply this by negative 3, negative 6t1 equals negative 6t2 plus 15. And then if I add these together, that cancels, well, adds to 0, I should say. I still have that minus 10. These add to 0. And then I have, negative 10 equals 15. No, it doesn't. What that's showing me is I'm not going to be able to solve for T1 and T2, so these have to be skew. If you end up in a place where you have an unsolvable pair of equations, it's automatically going to be skew. All right. Just to show you what would happen if we did y and z, because it looks different, I'm going to go through this and do this another way. I'm going to use y and z for both sets. So 2t1 equals 2t2 minus 5. T1 plus 6 equals 3t2. I'm going to multiply the second equation by negative 2 and add. Negative 2t1 plus 2t1, those will add to 0. Negative 2 times 6 is negative 12. Negative 2 times 3 is negative 6. So negative 6 plus 2 is negative 4. minus 5. Oh, this one does become solvable. So let me just follow it through. I'm going to add 5 and make this a negative 7 equals negative 4t2. So t2 is 7/4. Yes, it's a fraction. It's not the end of the world. Don't get all upset. 2t1 equals 2t2, which is going to be 7/2 minus 5. So t1 is going to be 7/2 minus 5, which is 7/2 minus 10/2, which is negative 3/2. Divide that by 2, I get negative 3/4. Yucky, but fine. I got two t-values. But what's going to happen now is when I plug those t-values back in, you're going to see that 2 of the coordinates work and 1 does not. So let me show you. If I plug negative 3/4 into t1 for L1, negative 3/4 plugged into this equation up here is going to be, let's see, x equals negative 9/4 minus 5, which is negative 29/4. Y is going to be negative 3/4 times 2, which is negative 3/2. Z is going to be negative 3/4 plus 6, which is really 5 1/4. I'll use a mixed number. I normally hate them, but I'm dealing with it. And then in L2, I'm going to plug 7/4 into here. So L2, 7/4 plugged into here is going to be 3 times 7/4, which is 21/4. Already the x's don't match. Let's check the y's and the z's. Y, 7/4 is going to be 14/4 or 7/2 minus 5. Right? Right. 7/2 minus 5. Sorry, I thought I did something wrong, but I didn't. 7/2 minus 5 is going to be 7/2 minus 10/2, which is negative 3/2. And then z, 3 times 7/4 is 21/4, which is 5 1/4. So what you'll notice now is since I set y equal to z, your y's and your z's match. But my x's this time did not match, which means that these lines are skew. I can find a place where the y's and the z's match, but the x's do not. Obviously, it was quicker to go the green and purple route. So if you are setting this up and you get to an unsolvable place, just stop there and say skew. But it's not always going to look like that. Skew lines are either going to look like an unsolvable thing or a thing that really wants to be solved, but one of your coordinates does not match up. All right, a little bit more here. Determine whether AB intersects CD. Well, that means I got to write the whole lines from scratch here. If you think you understand what's going on, feel free to pause this, do it yourself, and scrub through the video to the end. If you think you need to see it, keep listening. I'm going to go a little bit quicker. So if I want line AB, that is going to be x equals 3, y equals negative 7t plus 5, z equals negative 7t plus 7. X is just negative 3 because the vector from 3 to 3 is the 0 vector, so it's 0t plus 3. The line CD is going to be x equals, well, my x goes up by 1, so that's going to be 1t minus 1. Y goes from negative 3 to 1, so 4t minus 3. Z goes from negative 2 to 8, so that's 10t minus 2. There's my two linear equations. Do they have a chance of being parallel? Well, this is the vector 0, negative 7, negative 7. This is the vector 1, 4, 10. Nope, not even close to be parallel or coinciding. Now I want to see if they intersect. So 3, t minus 1. So 3 equals t2 minus 1. Negative 7t1 plus 5 equals 4t2 minus 3. I can just solve this by solving for T2 right off the bat and ending up with T2 equals 4. Plug that in down here. Negative 7T1 plus 5 equals 16 minus 3. Negative 7T1 is going to be 13. Take away 5 is what? 8. So T1 is negative 8/7. Weird but true. Now let's see what happens to my coordinates. L1, which is AB, I'm going to use negative 8/7. So x equals 3. Y equals negative 7 times negative 8/7 is 8, plus 5 is 13. Negative 7 times negative 8/7 is 8, plus 7 is 15. And then for CD, x, let's see. Well, x, I got to use T2 equals 4. 4 minus 1 is 3. So far, so good. Y, plug 4 in 4t minus 3, so 16 minus 3 is 13. Still looking okay. Now let's see what happens with z. 4 times 10 is 40, minus 2 is 38. 38 and 15 are not the same. These are skew. Find the parametric equations of a line that intersects this line at the point negative 3, 5, 3. Find the parametric equations of a line that intersects this line at the point negative 3, negative 5, negative 3. Here's the good news. This couldn't be much easier. I have a line. Since they tell me it's got to intersect that line at the point negative 3, negative 5, negative 3, I'm going to assume that negative 3, negative 5, negative 3 is on this thing. So let's say it's right here. You know what? I'll even draw on my marker. I don't know if you can see that dot. There it is. You can see the dot. I want another line that intersects there. Could be this. Could be this. Could be this. Could be that. Could be that. Could be... There are an infinite number of lines that do that. Like so many. So all I need to do is write a linear equation that contains this point. Any linear equation that contains that point. So let's make one. X equals t minus 3. Y equals t minus 5. Z equals t minus 3. Done. You can put any numbers in front of those t's you want. It would still intersect at negative 3, negative 5, negative 3. Done. Fantastic. It's over. I need a joke. I still don't have one. I should have looked one up in between the last video and this one, and I didn't. Let's go with knock knock. Who's there? Interrupting starfish. Interrupting starfish. I did interrupting starfish with the camera. I don't know if it's funny, but I think it's funny. And I'm done. Mrs. Vibber is out.